Hello, and welcome to my Lab 2 presentation. My name is Anand Jha. In this lab, we will computationally determine the amount of excess charge on an ordinary object. Let's begin. To introduce this lab and to state its main purpose, this lab is quite similar to Lab 1 in that it will ask us to show how matter can be temporarily charged and also ask us to calculate the net charge on a piece of Scotch tape. This lab differs from Lab 1, however, in that it asks us to treat objects as having multiple charges and not just reduce it down to a singular point charge. This will make it so that we have to computationally calculate the net charge on our piece of Scotch tape, and we plan on doing so by using Python. Some fundamental principles that this lab will go over is Newton's first law of motion, which states that any object experiencing a zero net force will stay in uniform motion, and also the electric field generated by a charged rod with a finite length. We'll also cover basic topics like the fact that like charges repel while opposite charges attract, and that neutral objects can be attracted to charged objects through dipole moments. The experiment itself for this lab is quite similar to Lab 1 in that we will make two pieces of electrically charged tape and make one of those pieces suspended in the air by the electrostatic repulsive force from the other. However, in this lab, we will computationally determine the electric charge on each piece of tape in Python instead of just using Coulomb's law. From there, we will calculate the number of electrons lost or added to the tape and calculate the ratio of the number of electrons lost or added to the number of atoms present. Some assumptions that we plan on making for this lab is the fact that the charge on both pieces of tape are equal to one another, and that atoms are perfect squares and there are no gaps in between them. And we'll also assume that the gravity and electrostatic forces are the only two forces acting on the piece of tape. This is some background info for this lab, which is the exact same as Lab 1, and then the data and observations are also the same as Lab 1. So here's our glow script model for this lab, which is where the differentiation from this lab and Lab 1 truly show. As you can see on the left, Lab 1, we treated each piece of tape as a singular point charge, and we got a charge of about 5.2 times 10 to the negative ninth coulombs. In the right picture, we show that each piece of tape is multiple charges in a line, such acting as a charged rod essentially, and that there are multiple electrostatic forces that are all summed up. And through this process, for this lab, we got our charge of each piece of tape to be equal to about 2.59 times 10 to the negative 8th coulombs. So almost a order of magnitude in difference from Lab 1. So using this new charge on each piece of tape, our calculations / results for this lab greatly differ. We saw that the electron deficiency is equal to about 1.62 times 10 to the 11th electrons, where in comparison to Lab 1, it was 3.28 times 10 to the 10th. So again, almost a order of magnitude difference. And we also saw that our ratio of deficient electrons to atoms present was about 6.71 times 10 to the negative 7th, compared to in Lab 1, where we stated that it was 1.36 times 10 to the negative 7th. So we can see that by using this computational model, instead of just using the basic Coulomb's law, our results differ by almost an order of magnitude in every aspect, meaning that these two processes, which feel somewhat the same, can produce drastically different results. So in conclusion, we determined that about 1 out of every 10 million atoms were lost, or 1 out of every 10 million atoms lost an electron on each piece of tape, which is about the same thing that we got in Lab 1, but we also saw that using our computational model can give drastically different results, as stated in the previous slide, because of the fact that we can be off by an order of magnitude. Some additional questions that we can ask for this lab is, what if we had modeled our pieces of tape like point charges? In that case, we of course would have gotten different results, which can be shown in the deviation from Lab 1 to Lab 2. And we ask ourselves, why do these estimates differ? And that is the simple fact that because there are multiple charges, we produce horizontal force vectors instead of just perfectly vertical force vectors in Lab 2, whereas in Lab 1, we produce those perfectly vertical force vectors. And to ask which value is more accurate, well, you would probably say that Lab 2's value is more accurate, as it is a better depiction of what is happening in the real world, as objects are consisting of multiple charges and cannot be reduced to just one singular point charge. That is all for my Lab 2. I hope you enjoyed. Thank you very much.